This is actually part 2 of M18. It's the lab project, if you want to call it that we didn't do in the manual. So in the manual, we only go so far. We're trying to limit the number of pages in each of these manuals to under 300, around 260, 270. That's a lot of pages, and we don't want to, it's not a matter so much of wasting paper, but it costs more to print it. It's more to manage, it's harder to handle. What we're going to discuss now is all the other stuff that we did on M18, that lab project, that we didn't do in the manual. So this is additional stuff. Move instruction, FIFO, LIFO, load, unload. And we're typically going to do this on quite a few of the lab projects where if you don't watch the videos, then you don't get as much. Now, you don't need to watch videos. You don't need to purchase the videos. You can do the lab project strictly from the manual, and you'll learn plenty. But if you purchased the videos, and of course, if you didn't, you don't know this because you're not watching me say this anyway. Okay, so let's get into some FIFOs, LIFOs, move instructions, and stroke counter, and some other miscellaneous code that we threw in for grins. Okay, we've pretty much worn out this particular lab project as is in the manual. But just to quickly go through with what we have so far, if we push the extend cylinder push button, we energize a solenoid, and then we have logic that simulates the cylinder extending down here, this rung of logic. These two moves right here are moving 0 into these variables to clear them. So if we click on 5, input 5, you can see that rung goes true. It resets any faults and anything else we've got connected to input 5. Now remember that a little piece of code like this, if it were in an actual application, would have other hooks, other connections to other part of the process. We don't have that here, so that's why we use inputs like IN05, reset push button, to do things that other parts of a real process would do to clear it to make ready for the next instance or incident. And we also had our fault logic, and then here if we have an extend or retract fault, we turn on output 0. We also created this rung of logic to simulate a sticky cylinder. In other words, if I turn on input 4, it's in neither position. In other words, if it's not extended and not retracted, of course that's not true. So if I turn on input 0 to make it extend, you see this is true while it's extending. And so because I'm using this to inhibit cylinder motion, then down here I'm going to make it time out and fault. Well, we don't want it to fault, so we'll turn off 4, turn off 0, let it retract. Then we'll go back up here to where we have cylinder fault. See, we have an extend fault. And I'll turn on 5, and that resets it. And all we're doing here is demonstrating, and I already explained this before, that if the current extend or retract value is greater, less is not a bad thing, but greater is. So if it's greater, then we want to move that into this variable. That way this variable always represents the longest interval for extend or retract. Now let's jump down to the new stuff. In other words, this is the extras that I threw into this discussion. I'm using a FIFO and a LIFO. A FIFO, F-I-F-O, first in, first out. A LIFO is last in, first out. If you wanted to compare these to a ammunition magazine, like for a pistol or a rifle, the first in, first out would not be possible with an ammunition magazine because it's the last one that you shove into the clip or the magazine, this is going to be the first one out. So the LIFO over here would behave like a ammunition magazine or clip. So we have a FIFO and a LIFO, and they are both file instructions that work with files. Now in this case, we're going to keep it short. We're going to use a length of 5 for our file. And the reason that we're doing that is because I'm not patient enough to sit here and operate this virtual cylinder 10 times or 100 times to get the stack full. And over here we have 2 stacks, extend stroke records 2 and just records. So if you look here, you'll see that the FIFO is extend stroke records. The LIFO is extend stroke records 2. So we're using the exact same circumstance to load both a FIFO and a LIFO. That way we can demonstrate the difference between the two. And then right below there we have the unload instructions to unload the FIFO and unload the LIFO. And we're going to use input 6 to do this. Now, if you were trying to maintain a running list or a running file of extend and retract time intervals, then you would unload these every time it hits full. You see both of them say false for full, but for empty they show false as well, because if you look over here you see that we have a 5-second extend stroke for both of these, both the FIFO and the LIFO. Now the reason that's in there is because remember I had input 4 turned on and I let the false time out. So I'm going to hit 5 to make sure everything's reset. Now I'm going to hit 6 to unload. So watch the value here. See, 5 seconds, 5 seconds. I'm going to hit 6 and that's going to unload both of those. Now with only one value in there, that if there's only one value in your stack, it's the first one in and it's the last one in. If you had 2, that would be 2 different values. One would be the first in, the other would be the last in, but there was only one value. So let's put some values in here to demonstrate this thing. To do that, we're going to turn on input 0 and I'm going to let it the simulation time out, and you see that we have something like 2.1 seconds. Now if we go back up here, you'll see that I have 2100 milliseconds for my simulation of extension, and I have 1800 milliseconds to simulate the retraction. And this is, the simulation results in this virtual sensor, extended proc switch, retracted proc switch, these going on and off based on some simulated interval for extending and retracting. And that's what we're recording here. Now I have this for retract as well down here. So down here are my retract records. This is the load and this is the unload, but I only have it for a FIFO. I didn't want to repeat the whole thing for both FIFO and LIFO because it works out the same. It's the same logic. It's just that you're recording the extend times here, and down below you're recording the retract times. Okay, so let's turn off the unload because we don't want to be continually unloading. I want you to, I'll do that one more time to clear this out. I also want to go down to this is a special type FIFO, LIFO configuration or control. So this is kind of like the R6 control data types that you had in PLC5, SLC 500, Micrologics. If you are RS Logix users or RS Logix Studio 5000, it had a type of data type called a control data type that was used for all the instructions of this type, and it had a length and a position. So here you see I have cylinder 1 extend length and position, cylinder 1 extend 2 length and position. That's because you can't use the same instance for both the FIFO and the LIFO. See, cylinder 1 extend, cylinder 1 extend 2. In other words, the second one, you could have made it B or X, just so it's different. It has to be different. If you don't do that, what happens is it executes this one first, and it moves the position up once, and then when it executes this one, so you end up with the values stored in every other position instead of every position. These are the things you learn the hard way. You need to use the same control data instance for both the load and the unload. So you see, here's extend 2, and here's extend 2 down here. So you have to use the same FF_LF_CON. You have to use the same instance for both the load and the unload. And what we're loading is extend stroke records here, and we're unloading from extend stroke records here. Here we have extend stroke records 2, and here we have extend stroke records 2. That's why, and by the way, what you'll notice is 5 stays the same because that's the length. That's the control of the sequence of the false to true transitions and where it's loading and unloading. The length stays the same, but the position will change. So just to demonstrate that, I'll turn that off, let it retract, and then extend it again. See, the position goes to 1. Let it retract, and if I do this again, the position would go to 2. So let's go back up to our data here. These are our 2 stacks of 5 time. Notice that this is a time data type, 2 seconds, 109 milliseconds, or you could say 2109 milliseconds. And you'll notice that here it displays it as seconds and milliseconds. Here it's displayed as milliseconds. Okay, in both of these, 2109 milliseconds. That's the first element, so to speak, of the stack. As you're playing with this, you need to pay attention to what's false and what's true. It's not full and it's not empty because there's a value in there, right? If I unload this, now you see it's empty. Both of these are empty. All of these variables are useful in your application. Now, the only one that we're not going to explain a lot is some of the variations that you can do in these variables. And if you want to see more information about that, here's the help file for FIFO load. Okay, and it says loads 8-bit, 16-bit, 32-bit, or 64-bit data into a user-created array called a FIFO stack. Now, I'm not going to go down and read all these conditions, but here are the variables. And you can see execute, source, FIFO, FIFO configuration, done full empty, error, and error ID. So error is, there is or isn't. The error ID is the actual way to identify what the error is. And if you go to the help files, you can read the important stuff. One of the more important ones here is right here. The input can be any elementary data type. And notice it shows double word real time, that's the one we're doing, date, etc. String is not supported, so you cannot stack strings in a FIFO stack or a LIFO stack. And here it explains the configuration control. Notice it says the same configuration must be configured for the FFL and FFU instructions for the same stack. Okay, and there's no reason to read the rest of these. Here is your configuration data type, number of elements used for the FIFO operation, maximum limit 1024. That's important to note. And then the position determines the next available location of FIFO for the source or removal, for entry or removal, meaning load or unload. Okay, so let's pull this back out of the way here. we've got nothing in there right now, right? It's all unloaded. So let's do this, turn on 4 for a couple seconds and then back off. That way it inhibits the extension of the cylinder. Now as we turned on the sticky cylinder, you notice that both the FIFO on the bottom, extend stroke records, and the LIFO on the top, both loaded that extend value into element 1 of that 5-element array. Whether it's a FIFO or a LIFO, it's going to load it in the same position. Now let's do another one, and we'll leave it timeout to 2 seconds, 2.1 seconds. Now let's do another one and hang it up maybe a little bit longer. If I go too long, well, I didn't go as long as the first time. See, that's 3 seconds, 4, 6, 8 instead of 6, 5, 7. So I'm just guessing when I do this kind of stuff. Maybe that one will be a little longer. Okay, 4 seconds. Okay, I wanted some different values in there, so we'll do one more. Now we've got 4 in there, right? Notice that it's not full and it's not empty. They both say false. So let's do one more. Just let it time out for the standard value. When I say standard value, you know what I mean. I mean the down here or up here in our 2100 milliseconds. Now the way we're capturing these values and stopping them is what's giving us that extra little 9 thousandths of a second. Notice it's 2109 instead of just flat 2100. We're not concerned about that. What we're concerned about here is the function of the FIFO and the LIFO. Okay, so notice that both of the stacks look 100% identical. Same values in all 5 positions. So now what we're going to do is we're going to unload. And we're going to unload both of them simultaneously. We've got input 6. This is the way I've got this screen set up. I can only capture from up here down to about here. There's more down below that, as you can see. So I could scroll down and show you the unload for the LIFO, but we'll just leave it like this. And I'm going to turn on 6 once. And I want you to notice where it unloads from. This one is 3657, that one's 3657. So unload once, and notice that the number 1 element for the FIFO unloaded the first one that was in, not the last one. This one unloaded the last one. So last in, first out. So this was the last one in, it was the first one out. But it unloaded it from the same positions. Well, it didn't. This one unloaded it from the top. We'll put another value in there rather than get you confused. Okay, 2.969, 2.969. Okay, so at the top you get 3.6, and this one you got 2.6. So make a mental note of that, and then let's unload. Which one's it going to unload for records number 2? This one. This is the LIFO. The last one in was this one, right? 2.969. This was the last one in. This is a FIFO. So let's do one unload. Notice that for the FIFO down here, the last one in was that 2.969. That's still there. It went up one in the stack because it unloaded this one. Or I'm sorry, it unloaded and they went up. That's still at the top. So if I unload again, watch the top one here, 3.657. That one stayed right where it's at, but this one moved up. So see, this one's unloading because remember, this is the last in, first out. These are the last ones in down here, so they're the first ones out. So it's unloading from the bottom. This one is actually unloading from the top. The reason that the zeros show up in the same place is because they're moving up in the file. As they unload from the top, everything moves up. As they unload from the bottom, the unloaded position is now 0. So if I guess the other thing I could have done is had a different trigger for unload for both of them. And you know what? I think I'm going to do that. I'm going to pause, change that, and come back. Okay, here we are back again. Notice now I have input 6 over here in the logic unloading the LIFO, and I have input 7 unloading the FIFO. So unfortunately, when I went offline, changed things around, and downloaded, I could have done this online and I wouldn't have lost my values here. So let's put some values back in there. We'll let the first one be the 2.1 seconds, more or less. Then we'll make the second one something longer. Okay, I have the same two values in there. Now I can unload anytime I want, but I like to have it full. So let's put some more values in there, get something longer. Okay, 2, 3, 4. If I go to 5 seconds, it'll fall. I will do something a little shorter, 2.3. And 2.9. I'm going to unload over here the FIFO first, okay, because that's the first one we did. Now, so watch the values on each end of the stack, 2.9, 2.1. So I'm going to unload the FIFO by turning on 7. One more time. Watch down here. You're going to see you can't see these moving up. But look at 2.9 and 4.2. Now watch what happens. Notice that 4.2 disappeared. So it unloaded from the bottom and then moved them up. So it's unloading the one on the top, so another 0 appears in the bottom. In other words, as the remove, remember this is a FIFO, it's first in, first out. So of these two right here, watch. Which one's going to disappear, 2.4 or 2.9? 2.4 did. So the one on the top disappeared. Now let's try our LIFO. So we'll turn off 7. And which one's going to disappear, 2.1 or 2.9? 2.9 disappeared. So this one disappeared, not the one on top. Down here, the one in element 1, it disappeared with each unload. Up here, the one on the bottom disappears. So if that's true, then 2.4 should disappear when we do this one. Now 4.2 should disappear. I know this is hard to keep track of. It might even seem confusing because it's hard to watch these stacks. That's why you have to have different values in there. Otherwise, you'd have no idea what's going on when you're watching it. Okay, so FIFO and LIFO, load and unload. I also use something down here. I'll just throw this in. I wanted to count strokes. In other words, I wanted to count each stroke of cylinder 1. And I mean full stroke, which means I don't want to make a count unless it fully extends and fully retracts. I don't want short strokes, half strokes. The conditions that I'm using are And I want you to watch this. I'm going to turn on input 0, and then after 2 seconds or so, it's going to hit the extend proc switch and turn on this bit. This bit is going to seal itself in until this goes false. Now this is going to go true as soon as we move off of the retracted switch. So there'll be a time when either input 10 or input 11 are on because the piston is between the end of strokes, okay? So I'm going to turn on output 1. Well, I'm going to turn on input 0, which is going to cause it to extend. So this comes on, and then after 2 seconds, that comes on, and this is a pulse rising. So that's why it's black now, because it's no longer true. It was true for one scan when the system first saw that the extended proc switch was on. So it turned on this bit, which sealed itself in until, now watch, we're going to retract. So turn off input 0, input 0, and then this will go on after 1.8 seconds. This goes false and it drops out this. And down here we're counting these strokes. Now notice there's several ways I could do this. I could count it when this goes on, right? In other words, I could put in a pulse rising here, or I could have just a straight direct contact. In this case, I'm using a falling. In other words, I'm counting when full stroke bit goes off, because that can only happen if you completed a full extension and retraction. Watch again. Turn on input 0, it's extending, it extended, it's retracting, retracting, full stroke goes off, and we count up 1. So this is not, these aren't instructions that you haven't used before. You know, true off, pulse rising, pulse falling, and count up. So just another little piece of code thrown in for those of you that are watching the videos. Thank you. The lectures that we have on YouTube are free. We also have some lectures by subscription on Vimeo. Some of the newer video discussions that we've posted will eventually end up as a subscription on Vimeo. Enjoy them while they're free on YouTube. The project manual for 500, RS Logix 500, MicroStarter Lite, typically using a MicroLogix controller, is this orange and black manual available at the PLC University website. And it has a set of lectures on Vimeo that support it, and some of them are free on YouTube. And then we have a set of RS Logix Studio 5000, Logix Designer, physically, 2 separate spiral bindings. And then our connected components workbench with Micro 800, part 1 and part 2. I think we're going to come up with a part 3, 3rd edition. These manuals are available at PLC University, and the lab discussion lectures, some of them are free on YouTube and others by subscription on Vimeo. Have a good day.